So, in the last video lecture and the one before, then we really focused on the neurocorrelates of the UAMA model. So we covered all of this and how all of these main areas help provide normal anxiety responses and helps control anxiety, and how dysfunction in these areas are thought to lead to anxiety. Now, this is talking about GAD, and we also talked about how some of these areas, like the AMCC, are involved in PTSD. But what about OCD? So OCD has some different areas that are thought to be involved in it. So again, remember that OCD has an obsession. So this is persistent intrusive thoughts that cause excessive anxiety. And then there's compulsions. So those are the repetitive actions focused on relieving the anxiety that's associated with the obsessions. So remember, the compulsions don't alleviate the obsession, it just relieves the anxiety. So the neurobiological model of OCD involves several different systems. The first is the amygdala, where here this is the abnormal fear response. We also see increased ACC activity associated with the compulsions. So that's the anterior cingulate cortex. And then we also see the basal ganglia hyperactivity associated with those repetitive areas. And so we're really going to focus on that basal ganglia, because that's something that we haven't really talked about with when talking about the other areas involved in anxiety. So again, we see the abnormal function in the caudate correlates with stereotype behavior and perseverance. So the perseverance is the inability to turn attention to new tasks, so you get really stuck on it. And it's comparable to repetitive stereotype behaviors elicited in animals by cocaine or amphetamines. So again, if we look at, there's this little area right here that the arrows are pointing to. That is the caudate, or the basal ganglia. And you can see before treatment, so whether before drug treatment or before behavioral treatment, it's very red and large. And then after treatment, whether drug treatment or behavioral, we see it decreases. So that's how the basal ganglia is associated with OCD. Now, when talking about the neural correlates in anxiety, we have three different kind of pathways that are thought to be involved. It's really more like one pathway, but a little different. We'll call it three pathways that are involved in possibly causing anxiety. So we're going to break those three down. So the first one is the direct pathway. So the direct pathway is pictured here. So in this one, then we see excitatory input. So excitatory is going to be green, guys. And remember, excitatory is almost always glutamate. So we see excitatory input from the cortex. And it's going to go to the striatum, specifically the medium spiny neurons. That's what MSN stands for. And then the striatum is going to send inhibitory output to different areas. And so the inhibitory is in red here. And again, when I say inhibitory input, I mean it's sending GABA. So the striatum is sending inhibitory information to the interior globus pallidus right here. And it's also sending inhibitory information to the substantia nigra, particularly the substantia nigra pars reticula. That's a little more specific. Now, because it's inhibiting this area, then what it's going to do is it's not going to be able to send more information, right? So by inhibiting the substantia nigra cannot send its own inhibitory information to the superior colliculus. And same thing, the interior globulus, because it's inhibited, it cannot send its own inhibitory information to the ventral thalamus. And because it's not inhibiting the ventral thalamus, then the ventral thalamus is able to send excitatory or glutamate projections to the motor cortex. Okay? So pretty much what it's doing is the cortical input tells the striatum, okay, go ahead and turn off the interior globulus and the substantia nigra. And what that does is it allows the ventral thalamus to send information back to the motor cortex, as well as for the superior colliculus to continue to do its job. So the excitatory projections to the upper motor neurons of the cortex that I have here, this is the ventral thalamus, that's what VTH stands for, and then the substantia nigra, PR, so that's the yellow dot here. It's excitatory projections to the superior colliculus controlling eye saccades. So the net output of the direct pathway is disinhibition of motor output to the cortex and substantia nigra through inhibition of toxic inhibitory activity. Okay. So now we have the indirect pathway. So the indirect pathway starts similar. So we've got the cortical input to the striatum, MSNs, again with glutamate. So it projects to the external globulus pallidus. So remember last time it was only the interior. This one, it says it goes to the exterior. And that prevents the exterior globulus to send inhibitory information to the subthalamic nuclei, which can then now send its excitatory information to the interior globulus pallidus, which will then send, so by activating the interior globulus pallidus, we get the inhibitory projections to the ventral thalamus, which means that the ventral thalamus no longer sends its information to the motor cortex. And you can see that in the indirect pathway, the substantia nigra is not involved. Now, the last of the pathways I want to talk about is the dopaminergic balance. So this is kind of using dopamine to balance these two pathways. So dopamine plays a gating role and balance activity between the direct and indirect pathways. So activation of the nigrostriatal dopamine pathways promotes the direct pathway over the indirect pathway. So this makes sense because remember that the D1 receptor is excitatory and the D2 receptor is inhibitory. So in Parkinson's, then we see the loss of the dopaminergic projections shift activity to the indirect pathway. But in anxiety, then it's we see a shift to the direct pathway rather than the indirect